Today I'm going to talk about the procedure of construction, step by step, so you can understand how construction works. Most architects, they don't go on site very much, but rest assured, I've worked for a contractor for 10 years, so to celebrate that, let's do 10 stages of construction. Number 1, building permits. So before you even start construction, you need permits. It's a criminal offence if you don't have these permits. It varies whatever country you're in, really. Planning permission, a set of architectural general arrangement drawings, which are general plans, sections, elevations, and the site plan. And then you usually need drawings in a bit more detail after that for building regs approval, so everything abides to the building construction codes. That's usually the building permit. Usually structural engineers drawings as well, and maybe mechanical, electrical and plumbing engineer drawings. You've sent that information to the local government, whatever department that is, and they approve it and you get a permit for that to build. If you start building without that, they have a right to take it down or force you to remove it, or you could even be fined, or you could even be put in prison. If you want to know that about permits in more detail, I just did a video on that. You can watch it up here or link below. Now on to number 2, mobilization. This is when the site team comes to site. They might have a temporary site office, water, electricity, so people can stay on site, do the work. So they're establishing a temporary office there. They're going to secure the boundary with fence for safety and security. And also they're going to clear the ground so vehicles can get in and out safely. Right now on to number 3, site preparation. This involves marking out the building on the site. Now, setting out the project, like putting dimensions from the boundary to setting out the perimeter of the building, the architect does that. Engineers don't do that. It's even actually written in the building contract at times, like the architect has to set out the project. I've worked on projects before and an engineer is setting out, why is the engineer setting out? They didn't design the building. Structural engineers only know like columns, foundations and structure and stuff. How are they supposed to know like where the building sits? So that's quite important. The architect sets out the location of the building and also the grids as well. So they'll start marking out the setting out of the building on the site and the grid lines as well. It's also good at this time to do a site logistic and erosion sedimentation control plan. What the hell is that? That's just a plan showing you how the site can be kept environmentally friendly. Crucial for managing construction activities and protecting the environment from the impacts of soil erosion and sedimentation. Water down the vehicles before and after they come into site, so you're not creating dust and dirt down the road. Take off the topsoil and then save that for landscape later on. Protect the existing trees so they don't get damaged during construction. All those kind of things. So everything needs to be planned accordingly. It's good for the architect to do a rough plan to show all that, which is also part of LEED requirements if you're doing a LEED environmentally friendly green building. After all that's been done, demolition will probably go on as well. If there's any existing buildings on the site, they'll be knocked down. Soil investigations should have all been done by now, pre-construction. Then a sub-base layer will be put down underneath the ground where the building is. What is the sub-base? Sometimes referred to as hardcore, is the dry mix that's placed below the foundation. So it's not concrete, it's dried stone or gravel. It keeps the foundations durable and stable. Now on to number 4, substructure work. What is the substructure? Well, substructure is the part of the building that's underneath the ground, so the substructure. The first thing that goes in under the foundations or on top of the sub-base hardcore that I just talked about previously is blinding. So what is blinding? Well, blinding is the first pour that goes underneath the foundation. It's just a thin layer of concrete on top of the sub-base. It keeps the bottom of the foundations nice and smooth and level. You might want to put a damp-proof membrane on top of it so it keeps it nice flat. Yeah. So now they can start foundations. To simplify things, let's say there's 3 types of foundations. There's footings, which go underneath walls and columns, and they have rebar inside them to support the concrete, which we'll talk about later. There's also raft foundations, which is a reinforced concrete slab which covers the entire footprint of the building that has rebar inside it as well. Then the third one is deep foundations, which you get stuff like piles, which are like columns that go down really deep into the ground for really tall buildings. There's different ways you can do that, like you could drill a hole and pour the concrete down. Okay, now the foundations have been done. Let's go on to number 5, which is the superstructure. What is the superstructure? Of course, it's the structure above the ground. So now they'll start constructing the columns, the beams and the slabs, the structure of the building onto the foundations. That could be out of concrete or could be out of steel. So when the concrete's being poured, it's important to put the rebar in correctly, and that's according to the structural engineer's drawings. They detail out all the rebar. So why does concrete need rebar? Well, this is polystyrene, similar to concrete. Concrete is strong in compression, but it's weak in tension. So to fix that, you put steel members into the concrete, which are high in tension. Like this, maybe like that. So obviously now, it's still strong in compression, but it's also strong in tension now. So that's how reinforced concrete works. So it's important to place those steel bars in the correct position, and that's on the structural engineer's drawing. So now on to number 6, building enclosure. So before, the structure was more like the skeleton of the building. So the building enclosure is kind of the skin and internal elements, so blockwork, windows, maybe curtain wall, glazing, doors, roof lights, and roofing to protect the building from weather. They'll be using the architectural drawing a lot more now, whereas before they usually used the structural engineer's drawing for the structure. Now on to number 7, mechanical, electrical and plumbing systems installation. HVAC, heating, ventilation and air conditioning systems will start to be installed. Some of this will be overlapping from the previous stages as well, so they might start this after the structure's been finished, so it might overlap a bit there. Electrical equipment, generators, LV rooms, transformers, plumbing, drainage, external drainage around the outside is important. This is why it's important to design it in coordination with the structure. So if you've got pipe that go through a beam, it's too late, you've already built the beams. That stuff needs to be planned out in the drawings originally. That's part of the architect's job, is to make sure the MEP is not clashing with the structure or the slab. Sometimes it might be allowed to drill into concrete and beams, get small pipes in and things like that, but this has to be carefully planned. So they have to make sure the systems integrate with the structure without compromising on the integrity of the structure. Throughout these stages, a lot of inspections will be going on as well. Now on to number 8, interior finishing. So tiles, paints, ceiling grids, fixtures and fittings, so like wardrobes, cabinets, joinery like carpentry, reception desks, so fixed furniture basically. A lot of the architect designs that, or it could be interior designer as well, so it'll be on their drawings. There's a thing called FF&E schedule, fixtures, furniture and electrical equipment, so it could be lamps, fixtures, like there's light fixtures, might have a wall lamp or a pendant lamp or something like that, or hotels like that stuff. So those kind of fittings as well. There will also be a lot of inspections around this time to ensure quality and readiness for the building occupation. And now on to number 9, which is something you probably forget, which is landscaping. Some of this will be overlapped with previous stages as well. It's important to put in plants and trees, if you've got new plants and trees, to install them as early as possible so they can start growing before the building is occupied, because it takes a while to grow these plants and trees. 6 months, a year, so it's good to put them in as soon as you can. So most of this will be done alongside general construction, but there's a lot of roads, pathways, gardens, planters. Sometimes now you've got planters on buildings, around buildings, water features, water fountains, hard and soft landscaping. There might be a landscape designer as well, so it might be really detailed. Yeah, lots of things that you can do. Now finally on to number 10, final construction. There's a couple of things left over here. Before they're given the keys, depends on the role of the contractor, but signage is a big one. I spend a lot of time on signage sometimes. Tenant signage, safety signage as well, like road signs, signs on generator rooms, electrical rooms, especially if it's a hotel or mall, there's a hell of a lot of signage. Toilet signs. Putting them in is not that much of a big job unless you've got electrical one stuff, but doing the design of them is quite a lot of work. And also this is when the final inspections come in. They're getting ready to check and inspect and adjust things so things are ready for building occupation. Now you can watch this video about the building permits, and if you're interested in this one, you might want to click that one as well. And I'll see you over there.